In this lesson, we're looking at the 6 trigonometric formulas that you need to be able to not only use but also derive for compound angles. Now, as you can see here, a compound angle is just an angle that's made up of 2 parts. They might be added together or they might be subtracted one from the other. Now, straight away, this looks like a lot of things to memorize. So let me ease your mind by showing you that these 3 are written on your reference sheet. So you don't have to memorize them, but the better you know them, the less you need to look things up on your reference sheet. Now, there's heaps of patterns in here that we can easily spot. If you know these 3, do you think you'd be able to quickly and easily generate these 3? Well, let's have a look. Comparing these 2, the only difference here is the sign. And sure enough, the only real difference is the sign. So plus, plus, minus, minus. That seems quite straightforward. Comparing these 2, with the plus and the minus, we have a minus and a plus. So you just use the opposite sign. Again, that makes sense. And this one and this one, the plus to the minus, we have a plus and a minus there and a minus and a plus there. So sure enough, if you have these in front of you, which you should have for every test and exam that you're going to do, you can generate these ones easily enough. But you need to know not just how to use them, but how to actually derive them. So I'm going to look at the proofs of all 6 because you need to be able to derive them yourself if you're asked to. Now, curiously, we're going to start with this one because if we prove it first, it's the easiest one to prove and the rest of the proofs pretty much follow on from it. So I'll have one video proving this one and another video showing how we can generate the other 5 from this. But before we derive and prove those formulas, how about we look at how you're actually going to use them so they've got some meaning for you. The main things we use them for is to find exact values for angles other than the ones that we already know how to find exactly already. So this is going to open up many more angles that we'll be able to get in exact form because up until now we've known the boundary angles like 0, 90, 180, 270, etc. And we've known angles like 30 degrees, 45 and 60, which we generate using those special triangles that are on your reference sheet, or you might have memorized sine, cos and tan of 30, 45 and 60 as exact values already. So that's one purpose for these compound angle formulae. Another purpose is that we can just rearrange trigonometric expressions so that they look different. And sometimes we just need to do that because it'll help us solve some certain problem. So we'll look at those as well. So firstly, finding exact values for these. Now, if I want to find the sine of 75, I need to think through some angles that I already know exact values of. So jotting them down over here, I already know how to find the sine of 30, that's a half. This one's 1 on root 2. This one's root 3 on 2. I also know angles like 90, okay? So how can I add or subtract angles to get 75? Well, there's often 2 ways to do it. For this one, I think doing 30 plus 45 makes a lot of sense. So I'm just going to go ahead and write it like that, 30 degrees plus 45 degrees. So now I can use the formula sine of alpha plus beta, where alpha is 30 and beta is 45, to say that's equal to the sine of 30 multiplied by the cos of 45 plus the cos of 30 multiplied by the sine of 45. And now I can go ahead and work out what all those bits are. I know that the sine of 30 is a half, so I've got a half times the cos of 45, which is 1 on root 2, and then I'm adding it to the cos of 30, which is root 3 on 2, times the sine of 45, which is also 1 on root 2. So I get this, and now I just need to tidy it up. I can see that up here I've got 1 on 2 root 2, and I'm adding it to root 3 on 2 root 2. Now there's a variety of ways you could express this, which would be equally good. I think that this is not quite finished. Let's tidy it up and say it's 1 plus root 3 over 2 root 2. I think that would be quite acceptable. Another person might say, gee, we don't want surds in the denominator. We could rationalize it if we were asked to, especially. So multiplying top and bottom by root 2, you could say it's root 2, 1 plus root 3, over. Now if I multiply that denominator by root 2, I'm going to have 2 times 2, which is 4, okay? So I could leave it like that, or I could expand out the top and say that's root 2 plus root 6 over 4. So there's lots of answers that are acceptable. And it's handy being able to switch between those so that if you've got a multiple choice question and what you generated doesn't look like it's there, you might be able to change it into a different form until you can spot one that is. Okay, so next one, cos of 105. Thinking of angles that we can join together here, 105 looks straight away to me like 60 plus 45. So that means I'm working with the formula cos of alpha plus beta, where alpha is 60 and beta is 45. So my formula says to do cos of 60, cos of 45, minus sine of 60, sine of 45. Now I can go ahead and sub in. Cos of 60, I should really have degrees in here all the way along. I'm a little bit lazy, sorry about that. So cos of 60, that's the same as sine of 30, that's a half. Cos of 45, that's 1 on root 2. Minus the sine of 60, that's root 3 on 2. Sorry, a bit messy. Times 1 on root 2. So a similar answer to what I got before, but this time I've got 1 over 2 root 2 minus root 3 over 2 root 2. So I could write that as, can you still see that? Yep. 1 minus root 3 over 2 root 2, or perhaps I could do what I did before and rationalise the denominator. I would get this, or I could even expand it out and write it like this. Now don't overfiddle with your answers unless you've got a reason to do so. As soon as you get to something that's pretty tidy, unless you've been specifically asked to rationalise the denominator, you could stop there. And now the last one, I've got the tan of 15 degrees. So I've chosen to do the tan of 45 minus 30 there. So applying that formula where alpha is 45 and beta is 30, I need the tan of 45 degrees minus the tan of 30 over 1 plus the tan of 45 multiplied by the tan of 30. So now you need to know your exact values for these. The tan of 45 is 1. Tan of 30 is 1 on root 3, and on the bottom I've got 1 plus 1 times 1 on root 3. Now there's a bunch of ways that you could tidy this up. Simplest way I think is probably just to multiply all 4 terms here by root 3. That way you're keeping the fraction equivalent but tidying it up. So 1 times root 3 and 1 on root 3 times root 3 is just that. And multiplying this by root 3 and multiplying this by root 3, I get that. Now you could stop there or you could keep on going. We could rationalise the denominator here by multiplying top and bottom by root 3 minus 1. That way on the bottom we've got the difference of 2 squares. So we're going to have 3 minus 1, which is just 2. That's nice and simple. And on the top we're going to have root 3 minus 1 all squared. Now would we stop there or would we keep going? How do you decide? Well, the key really is, can I get it any simpler? I mean, this is correct. This is correct. This is correct. Where should you stop? If expanding out and simplifying is going to make it look better, then have a crack at it. If it looks like it's going to lead you down a rabbit hole and waste a lot of time, or if you've got some clue that you don't really need to go that far, then you can stop. With this one, I can see that I'm going to get on the top here 3 minus 2 root 3 plus 1 all over 2. So I think this is getting simpler because now I've got 4 minus 2 root 3 over 2, which is just 2 minus root 3. And I think that's a much better answer now than what I had earlier on up here. So I'm sort of pleased I kept on going and I got it nice and simple. Now, if you're working with one of these and you want to check your answer, checking it is always a great idea. When they say they want exact values, you shouldn't be putting it into your calculator because your calculator will spit out a number that you don't recognise as 2 minus root 3. So you need to follow this process. But to check your work, why don't you just type in tan of 15 to your calculator right now, see what that is, and then type in 2 minus root 3. If it's the same thing, then you can be sure that you've got it right. And that sort of checking is a really good idea. Okay, now we've got an example where we need to basically just change the form of some trigonometric expression, and we can use our compound angle formula to do that. We need to put it into this sort of form. So start out by just reasoning that x is your alpha, 2 pi on 3 is your beta. Remember that as soon as you spot that, you can see that this is an angle in here. So 2 pi on 3, we're clearly working in radians, and that's 120 degrees. Quick way to work it out, I mean, we've got the slow way of working it out, which is that you take this and to convert to degrees, you multiply by 180 over pi. So effectively the pi's cancel, and you're saying, what's 2/3 of 180? But a quicker way to work it out, without having to think that through, is just to say, I'm working in thirds here. What's 1/3 of a pi? Pi is 180, 1/3 of a pi is 60, and I've got 2/3, so that's 2 60s. I've got 120 degrees. That way you're picturing what you're working with right at the start. So we can say that this is equal to the sine of x multiplied by the cos of 2 pi on 3 plus the cos of x multiplied by the sine of 2 pi on 3. Where in each case here, 2 pi on 3 is 120 degrees, remember that. So here, we're trying to put it into this form. We can leave the sine x and the cos x as it is. We've just got to work out what this part is as an exact value. And the cos of 120 degrees, just thinking over on the side here, well, that's in the second quadrant. So it's a lot like the cos of 60, but it's going to have a negative value because it's in the second quadrant, and all stations 2 central, cos is negative there. So I know that the cos of 60 is the same as the sine of 30, and that's a half. So here I've got negative a half times sine of x, just writing this part first and that part second. And then over here, I've got the sine of 2 pi on 3. Now the sine of 120 is exactly the same as the sine of 60, and that's root 3 on 2. So I have root 3 on 2 cos x, and I've put it into this form. So clearly A is root 3 on 2, and B is negative a half. This next example is a little bit more complicated. Given that sine of alpha equals 1/3, so we're not dealing with exact values here because that's not one of the exact ones that we know, and cos of beta is 4/5, where alpha is a cubed, so it's in the first quadrant, and beta is between negative pi on 2 and 0. Now, stop there. What does this mean? Negative pi on 2 means negative 90 degrees, but it also reminds us we're dealing with radians, so we need to have all of our work in radians for this question. And also it tells us that if beta is a negative angle between negative 90 and 0, then it's in the fourth quadrant. So jot down things like that, fourth quadrant and first quadrant, next to your question so that you can really see clearly what you're doing. We need to find sine of alpha minus beta and cos of alpha plus beta. Now we've got formulas for these two, and we can just generate out that formula, but there's going to be some things that we don't know. So before you go looking for what you're going to need for the formula, I'd say write the formula out, and then anything you need for it, you can figure out over on the side to put in where it's required. So the first thing I would do with this one is just start by saying, okay, the sine of alpha minus beta is equal to the sine of alpha cos beta minus the cos of alpha sine of beta. Now, what do we already have? We've got the sine of alpha, it's a third. Okay, so I already know that part. But I don't know, oh no, I've got the cos of beta, that's 4/5. So I'm good for the first bit. But over here, I don't know what the cos of alpha is. And I don't know what the sine of beta is either. So at this point here, I'm a bit stuck, and I need to do some work over on the side. So now we're going to draw a triangle that's in the first quadrant, that has a right angle, and it has my angle alpha in it. Okay, now if I know that the sine of alpha is 1/3, that's opposite over hypotenuse, I can use Pythagoras to fill this out. Now you can go through and write your whole Pythagoras working out if you want to and you need to. If you can do that sort of thing in your head, at this point it's fine to do it. So I know that 3 squared, 9, minus 1 squared, 1, is going to give me this side squared. So this side squared is going to be 8, so when it's not squared, it's the square root of 8, which is 2√2. Now, there's a lot there to do in your head, and if you want to set it out by saying 1 squared plus, let's call this x squared is equal to 3 squared, and figure it out this way, then that's totally fine. You might get root 8 and then say that's 2√2, and you've got your working there. Go ahead. Okay, now that I've seen this, I can see that the cos of alpha is going to be the adjacent side on the hypotenuse, and alpha is in the first quadrant, so cos is positive there, so there's no problem with the signs. So cos of alpha is going to just be 2√2 on 3. Now I've got to figure out what sine of beta is. Now, beta is in the fourth quadrant, so I'm going to draw myself a triangle that's down in the fourth quadrant that's got beta in it, okay, and a right angle obviously. Now I know that cos of beta is 4/5, and I can pretty quickly and easily see this is a 3-4-5 triangle. You can use your Pythag if you need to, but it's going to work out with a 3 there. So now I can see that sine of beta is going to be opposite over hypotenuse. It's 3/5, but also I'm in the fourth quadrant. So really importantly, sine of any angle down there is negative. So I need to multiply this by negative 3/5. Okay. So I've got this part, obviously you don't really need brackets with the multiplication. I'm sort of just putting them in to keep it really clear that I've done all of the steps. Now I just need to tidy up. So here I've got 4/15, and over here the 3's are going to cancel, so I'm going to have the negatives there giving me plus, what have I got, 2 root 2 on 5. Now, pretty easy there to make common denominators. If I multiply this by 3, it'll be 15, and I've got to multiply that by 3. So I'm going to have 4 plus 6 root 2 on 15, and I could leave it like that. Sorry, that's a little bit glary. Or I could factorise it and say that's 2 outside of 2 plus 3 root 2 all over 15. Or obviously I could write the 2/15ths out the front with the 2 plus 3 root 2. Any of these are fine. So don't overly fiddle with it, but when you've got something you're happy with, you can stop there.